Hello, everyone. My name is Christian Casaza. Today, I'm going to be talking to you about using open source data engineering tools to conduct some lightning fast analytics. I'm going to try to make this session as useful as possible to both open you up and tell people about the state of the world and how things are exploding with the open source data engineering, as well as to show you guys some tools I've built using them that help make it easier to work with and build with New York City Open Data. So let's get into it. So today, I'm going to be telling you first a little background on open source data engineering, then a little demonstration on the open data stack. Then I'm going to tell you a little bit more about what that is. Then in real time, we're going to build a new end-to-end data product locally in 10 minutes with AI. Then we're going to see how we can scale to the cloud using open source standards, and then my closing thoughts. What is data engineering? Data engineering in general is the process of moving data from one place to another and organizing and transforming it to make so it's ready for downstream use, whether it be ML or for BI or for automation. But in general, it's like you get data from somewhere, you're organizing it, and you're making it for use. More fundamentally, though, here's how I want you to think about data engineering. Think of data engineering as if you're ever working with data, it's your foundation, your offensive line, like your point guard. You need data engineering to set the foundation for everything else downstream. It doesn't, you might have the best data scientists in the world, really fancy models. You might have really great skill positions like wide receivers. If you don't have a good offensive line, you're not going to succeed. If you don't have good, solid data engineering, your data products are not going to succeed. And in general, like data engineering can have a few different concepts where it's going to have data generation, wherever it is, whether it's how you're generating it. And this is where data engineering is, this ingestion, transformation, serving cycle. And some other stuff, but let's focus on just the core stuff for now. Ingestion, transformation, application. Let's say that as the general purpose flow of data engineering. So ingestion, think of it like we're going to go get data from somewhere, whether it be a download link, we're getting it from an API, from a database, from S3, wherever. Data is somewhere in some format, whether it's JSON, it could be a CSV, it could be some other format. We're going to get it when we're going to pull it in and we're going to put it in somewhere common so that we can all work the data in one location in a common format. In this case, I'm using Parquet. So a common thing you might already do today is you're going to download a CSV from the New York City Open Data Portal and dump it into an Excel files to run a pipeline. What I'm going to show today is using the NYC Open Data Portal to download JSON, convert it into a Polars data frame, and then use Parquet files. The second step in data engineering is the transformation stage. So think after you've already ingested your data and you have your raw data you want to work with, transformation involves conducting calculations on it to clean the data, to combine it, to generate insights in the data that you can use downstream. This is the part where you're going to be able to kind of do your calculations. Now, historically, you might have a really basic version of this in Excel. In Excel, that transformation pipeline is using their query language, Excel functions, and then the Excel engine, which you're using on your computer. I think everyone's familiar with that. What I'm going to show you today is an example where instead of using Excel functions, we're going to use SQL as our language, and a tool is called DuckDB to power that. And then the last step of that engineering is the application phase. So this is where we're going to be able to use the outputs of our transformation pipeline to some type of use, whether it be a BI application, whether it be feeding into an ML training and inference downstream, whether it be automating something. What we're in particular going to be focusing on BI here in this talk, but in general, application is to make use of your upstream data transformations. Let's think of this as the data engineering in general. This is the flow. You're going to ingest data from somewhere, put it into a common form. Then you're going to transform it. You're going to run calculations on it to generate your insights, answer your questions. And then 3, you're going to display information. You're going to do some type of format. And now I'm going to talk to you more about, let's zoom out a little bit. So why am I talking about data engineering? And why do I think open source data engineering is so powerful? It's because right now there are 3 different megatrends that are all converging around data engineering that collectively all provide a 10x boost to the current state of the industry. And what's really exciting is these are all extremely complementary to each other. So you get 3 10x boosts, that's how you get a collective 1000x improvement in call-off performance and simplicity that these tools get. And what are those tools that can provide this incredible leap for open source data engineering? Cool. Better hardware, number 1. We have better hardware, but compared to a decade ago, compared to 2 decades ago when the foundations of data engineering space were created, our computers are just better and faster and cheaper. Number 2, open source data, error-based data standards. What used to only be possible from platforms and companies that invested millions of dollars in engineering talent to create stuff That's available all now open source. There are primitives for everything in the data engineering process, open source, freely available. And then lastly, we have modern coding tools that make it easier to use that software, and then LMs that make it even easier to use that software in general. So a little more details. Compared to this is a chart I got from another Duck founder who did in a presentation, and I reworked. So thanks to him. So basically, what happens is, over the last decade, computers have been naturally adding more cores, which allow you to have more processing power. The more cores your computer has, the faster it can process data. What used to back when Pandas and was first created, single core laptops were very common. Now, so many laptops, commodity, have 8 cores, 16 cores. They can chunk a lot of data. They also have more RAM, which means they can fit larger data sets in memory without having to chunk and distribute to others. So you combine more cores, more RAM, you can work with much bigger data sets than you could before, and also work a lot faster. It's not even talking about GPUs, which are another innovation on the hardware side, which, while it's early, they also produce another huge benefit in speed and performance for analytics data on a single machine. So even if we did nothing from the data space from the last 2 decades, just by virtue of our underlying hardware getting better, the space is getting a lot faster and cheaper. Number 2 is where it gets exciting: open source, Arrow-based open source data tech. And like I said, it doesn't really matter the exact technologies here. Don't focus on them too much. But what they represent is collectively, they all kind of hit different parts of the process in order to make it possible to conduct a data engineering pipeline. These standards over here, they give us a standard for data management for how do we store it. It's going to be a Parquet on a disk. It's going to be in memory in Arrow. And then eventually, when you get more complicated, Iceberg. These single node engines, think of them like super Excel engines. So it's like you can just import them. You don't have to set up any infrastructure, and you can crunch millions of rows of data, which I'll show you in a second. These data applications, instead of Power BI where you're clicking stuff and you're using that to visualize, modern tools allow you to use code to define how your BI, which makes a lot more version control, easier to build, faster. And then lastly, in order to orchestrate all these tools together, you have tools like Dagster and dbt, which come in to make it easier to use, which I'll show you in a sec. And then lastly, the third kind of key catalyst is modern coding tools. VS Code is free and easy to use for everyone and fully available and does the job for the most part. GitHub allows anyone to be freely make it, and they can share their work with others and also have built-in version control of Git. UV and Bun are kind of modern package managers that are very old. UV is a little over a year old. What they basically do is they are rewritten key stuff in lower level languages. So from their perspective, it just makes working with Python or JS or TS faster and simpler and less prone to error. So if I reduce it on my computer, it's much more guaranteed to work on your computer. And then lastly, LLMs. LLMs really just change it where this technology and this workflow is available to anyone. Really anyone. It does not require someone like years of experience of like coding. It doesn't require going to college for it. You can have these things both do it for you, but also more importantly, to teach you how the underlying code works. So eventually they don't become just like your click and accept all, become your partner, which I'll show you in a second. And what I really want to emphasize here is this is just getting started. We are very early stages of this, and there's only so much to go up. We're going to start off simple. We're going to start off with this, but there is no kind of like key or no one knows how do you use these tools all together in one flow. No one knows that. It's still early. This still needs to be discovered, and that's how we'll go. Cool. So now let's give an example. Talked a lot. Let's see what kind of how it works in code. So you can scan this if you want in order to see kind of the repo like that. What we're going to show is a data pipeline in which, number one, we're going to ingest data from New York City Socrata API. We're going to ingest it and store it as Parquet files. Then we're going to run a SQL transformation pipeline on those Parquet files. And then lastly, we're going to visualize that as a data app locally. Now, we assume as part of this, that in order to do this, you need to have done like the key 5 or get started coding locally, which is have at least a VS Code ID on there so you can run code. If you're using Windows like I am, WSL, which makes things a lot easier. UV for Python, Bun for TS and JS, and then Git for being able to do stuff. So let's jump right in. Our goal is to be able to produce this kind of live site here, which was able to kind of show basic information about MCA stats, which can track different ridership over time, and it allows us to be interactive. And so we can do here, and then for be able to check different stuff, different buns here. Cool. Great. So we're going to go here. We're going to start off right from scratch. So I'm going to open up WSL. And then let's see how fast we can go. So we're going to call it a random name. Cool. I'm going to open this up. We just get cloned this from GitHub. So now it's on our computer, ready to go. Cool. And so in order to do that, we're going to follow the instructions from there, which are just, all right, I already have UV installed, which I can check by doing that. Okay, cool. I have UV installed. Now, since I can just jump straight here to setup.sh. So in just a simple command, what it's going to do is it's going to use UV to set up your environment. It's going to install your packages. Because it's UV, it happens very fast and it installs really quick. It's also going to set up my env file. It's going to add in my API key, which for the case, it's a free API key. I don't care if you guys use it, but for the most part, get your own. And then from there, we're going to run kind of the command. So what's happening right now? And then hopefully it doesn't break. But looks like we're good. So we're going to open this up. So what this does now is it kind of gives you access to a local kind of DAG, which is in this case pretty simple. It kind of shows you, okay, we're going to be ingesting 3 data sets, and then we're going to be running a SQL transformation pipeline on them to produce them. So let's just materialize all. So what's going to happen when we just click materialize all? Imagine like you're a city employee and you built this secure custom. I want to conduct my BI and I need to get my data. So what it's doing, it's going to start a process. It's going to make 3 API calls. It's going to make 2 API calls, one to the Socrata API in order to download the daily ridership and the operations data set. It's going to then also download, I already previously downloaded the MTA hourly ridership data set. The MTA hourly ridership data set is very large. It's about 70 million rows. It takes about a couple hours to download it from Socrata directly if that fits some logic. What I've done is I've already kind of downloaded it, put it into Parquet files, and then put it in my R2 instance. That's why I'm able to download these much faster. So cool. So now what we've done is we've downloaded all the data into our local files in the open data, where each data set is a Parquet file or a collection of Parquet files if they're very large. Then what we're doing is using DuckDB, which is a tool that kind of allows like you do it, which I'll show in a sec. We're actually running a transformation pipeline. So actually it already ran. So it ran in about 54 seconds. So what we did is we downloaded about 70 million rows of data. It's Parquet files. We ran a SQL transformation pipeline over here, which we can find over in here. Just literal SQL transformations in a file, SQL code, SQL query, and then we do it. So now in order to check out our data. Using a growth tool. I can literally just go over here to our newly created data.txt file. Cool. Now this Nitsio tool allows us to see kind of like our data sets that we just created. So select. Cool. Which makes more move. Cool. Cool. So we can see our different data sets and then the ones we just created from the SQL transformation pipeline. Great. So now you're able to work with kind of like data sets that are tens of millions of rows very easily using SQL. Because DuckDB and these tools, they kind of have some tricks that are abstracted from us, but they have some tricks that make it so, hey, this is a really big data set. Usually my computer isn't very strong. It has some tricks to make it so even if your query is only going to use the data it needs. So it allows even weaker computers to work with tens of millions of rows. Data sets that you couldn't even dream of using in Excel, you can now work on your computer. And now let's check out the app. So now we want to do some SQL querying about it, like we all want to do it. So let's check out that dictionary. Oh, got to put this up. Oh, where is it going? Cool. So now we're going to run the data application, which is using kind of SvelteKit, which makes it lighter, makes it cheaper and easier to host online. It makes it so you don't need like a server to do it. So it makes it very fast and cheap to do it. So cool. So now we're going to run it. We've just downloaded data. It's using the output of our data from a SQL transformation pipeline to power the app. So now we're running it locally. It takes about a second in the first go for it to load typically. Great. So now our live web app, which is over here. All right, we want to check the work. We want to make sure it's all working. Great. Now we can run that locally. We can check it out, make sure, okay, great. And now if you want to make edits, like what's beauty about kind of this modern stuff is it's very easy to do that. So I'm just going to go into literally over here. And in order to make an edit, let's see. Let's Cool. And so now what you're able to kind of do is edit very fast workflow. You can, in order to create BI tools, you can kind of work locally fast. It's a very fast iteration loop. You can use kind of simple tools to make it easy to add in like a data table, for example. Let's say I just want to add a little data table. Great. So I add now just by having a little tool and access to my tool, you're able to add a nice little data table here. Same thing with here. What we can do here is now it turns BI from having to do clicks, and in order to recreate a BI thing, having to understand and memorize an exact BI click schedule. It's all code. You can use just simple markdown to kind of call in your stuff. You can use SQL and simple markdown to bring in components like a chart. You can change it up. So that allows us to be very powerful for that. Cool. And now let's go back to presentation. Cool. So now that's what I'm working on in general. Like that's an example of using these tools. So now let's talk about more kind of generally. What is this about? Like why are we here for doing it? What I'm working on. So am I still streaming on screen? Yes. So more broadly, what I'm currently working on is the Open Data Stack, which I'm finding as kind of an open source data platform for building public goods. So what I want to do is I'm just using these open source tools to build out public good data pipelines. I want to just really ingest data from government sources and to ingest them, clean them, create useful public goods that actually make use of that information. I'm starting here in New York City, and what we really do is I want to be a free and open source for everyone to use. And so here's the three core design principles of how I'm building this and why I think everyone should be involved for it. Number one, Arrow-based open source tools. Now, I glanced over this before, but now I'm going to come back to it. Apache Arrow is kind of like the basis of why a lot of this open source data engineering work is happening. So think of it as Apache Arrow as a standard way. No matter what tool you're using, data can be represented the same way, whether you're using, no matter the tool or the language you're using, whether it be R or Python or JS, you're using Databricks or you're using, DuckDB or Polars. It allows it to be the same in memory. So imagine like the world's ports. And imagine that every port had a different language they spoke. Just not perfect analogy, but we'll go with it. Imagine every port spoke a different language. So every port, in order to maintain global trade, they need to maintain about 100 English to French, English to German, English to Spanish. And every port also has to do that. French to English, French to Spanish. So imagine everyone in the world having that, and that causes coordination problems. Now imagine another language came along called Arrow. And it says, hey, everyone can just speak Arrow. So now instead of everyone maintaining 1,000 one-to-one connections, you have English to Arrow and Arrow to English. So now this gives everyone the ability to seamlessly work together. All these different data tools, they can all work on a similar common foundation. Now, breaks that out. That's also why a lot of these other data tools are happening. Because when you establish that hard initial part, we have a standard way of doing the in-memory, the language. Okay, now it makes it easier to coordinate. Now let's just have standardized, shipping containers. Let's just standardize how we also get the containers off the boat. By standardizing on this very core Arrow level on the in-memory format, we have all these other open source tools and make it easier to build downstream of. So we're focusing on that, focusing in this area. Number two, local first development. So a lot of the kind of common stuff with data engineering over the last few kind of years traditionally has been either using Excel and Pandas and like kind of local stuff, or as soon as you're done, bump it up. Like you can't do anything locally. You got to jump up to distributed compute. You need a big, powerful machine. But because of the catalyst I mentioned before, I believe local is actually coming back. You're able to work with very large, like millions of rows of data on most commodity machines with just a little kind of application work. So why I'm focused on local development is because I think it has a really increased chance for creativity. Because how many more projects aren't started because, I don't want to set up an account and put my credit card on that data platform. I don't want to have to, worry about my bill. I don't have to go to my supervisor and request an extra budget in order to try this. You can just get started locally for free. All the work you're doing is just sweat equity. So that's what's really beautiful. I think that how many more projects can be created from just smart people wanting to do something, it becomes more possible with local development. Another really critical aspect is the unified local and prod experience. Because of really annoying, whereas, okay, let's say you do all this work locally, you built a hey, it works, it's beautiful. And then, okay, great, we want to put it to production. We want to make it automatic. We want to put it in the cloud. Okay, great. We have to change all the tooling and interface for doing that now to move from local to the cloud. It's a completely different experience. That's terrible because that makes it very hard for newcomers to actually make something useful. It requires years of experience. By having a very similar local and prod experience, using the same engines you're using for querying, using the same tool, same orchestrator you're using locally as in prod, it allows a very faster development loop. I think more downstream stuff can be built by focusing local first and then building outward from there. And then lastly, learn by doing. Because you know what? Who in the world knows how to use all of these open source tools together in one singular flow to make it easy to build stuff? No one. That's the point. These are all new tools. There's no kind of like defined formula or playbook for how to use these tools in conjunction. It's all being discovered. And you know what? They're not really ready for the super prime time yet for the enterprises, where they have really big concerns of billions of rows, where they need to have very, very good metadata management, where they need to be able to have complicated multi-turn data engineering practices. They're not ready for that yet. And that's okay. Because we're starting early. The upside is there. So as part of this, and what I'm doing here, I'm just embracing learning by doing. Focus on just doing end to end, make it work, make something valuable, then focus on automating it, on expanding it, making it scale. Focus there. And as part of that, one quote I put on there that I really like that Jeff Bezos said, where people asked him back in the early days of Amazon, like, what do you think customers are going to want in 10 years? And what he says is actually, it's hard to do that. And especially, I think that's correct now with AI and all this happening. Like, how can you predict what's going to happen in 10 years? You really can't. What you can probably predict is people are going to want cheaper, faster, and simpler data. You can probably bet on that they're always going to want to be able to work with data that's cheaper, faster, and simpler. So that's part of doing that here. Let's just literally put our heads down, and I'm going to be building pipelines to make it cheaper, faster, and simpler to use this tool. So as part of that, that's why my main focus on the Open Data Stack is focusing on building public good data pipelines, because I believe there's a partnership between governments and nonprofits and the open data community can be extremely beneficial for everyone. Because governments and nonprofits have a lot of data, they have use cases for their data, and they have incentives to provide, be a friend of the government, grants, some type like public reputation for your help of open source. Whereas open data communities have cheap, fast, and good data people can use for building pipelines, and talented data practitioners who know how to use that technology. By creating a partnership between, open governments and the nonprofits with the open data community already kind of building these tools, I believe we have a really good sustainable feedback loop where we build public good data pipelines that actually serve a purpose while also developing the underlying open source data technology. So if that interests you, that's what I'm focusing on. How can we get these parties working closer together to accomplish, hit two targets with one arrow? Cool. And so now this is kind of the current membership of like the Open Data Stack. These are the technologies that are in it. Like it doesn't include everything I showed, but these are the ones that are in there. It's a membership list as well. Over time, I might change it based on how good it goes, but these are the ones that I like the UX and the overall experience the most so far. Cool. So now let's create one from scratch, and show it out. Nathan, I asked you to be able to predict and pick one at random. Do you have a link to a data set?
Yes, I do, and I have not shared this with you prior. So here is a data set.
Thank you. Cool. Great. Cool. Evictions. And we got 106,000 rows. Pretty not bad. So what are we going to do? Well, I'm cheating a little bit, but this point of here is to kind of show an example of workflow of how things might be in the future with AI. So I'm going to use this NYC one as a little template. So let's see how fast we can speedrun this. What we're going to do is open it up. A terminal. And get going. Oh. Cool. Great. And now we're also going to use this open source tool I made called Code Printer, which is a nice simple little tool for being able to share a code with an LLM. So I'll literally just get going from now. Cool. So now Code Printer just makes it's a simple tool I made with an AI to make it easy for you to take your local files you're working with and send it to an LLM. So now we're going to do that. We're going to use Grok, which Politics Design is the best for right now for public demonstrations because it gives good answers and also pretty fast. Cool. So we're going to go into this privileges clone. We're going to go into the prompt section, which I prepared beforehand. Again, cheating a little bit. Made them a little specific, but who cares? So we're going to literally just copy this, dump the prompt in, and we're going to go into our printer. We're going to go get the thing we just get cloned. We're just going to copy the pipeline files. Great. We're going to copy it. So let me just send it in. Cool. So now I sent that. While it's doing that, it's going to be analyzing this code and kind of getting a nice little answer of how to use it. In the meantime, let's go get the data from our new asset we're creating from evictions. So now I'm going to go over here again. Next prompt. Cool. So one, name of the asset. So NYC housing evictions. Let's go with whatever. You know which change earlier. Endpoint URL. All right, we're going to go at the endpoint over here for the JSON, just JSON. Cool. We're going to go grab it. Great. Cool. Now the column we want to use for the date column, for its date, which one can represent like a time series? Which one's a date column? Executed date. Let's use that. Cool. And then lastly, the overall depth. Great. So now we gave it the kind of MTA data. It was able to go through this. Now I'll just do it quickly, but this is a good technique for being able to learn new repos and how code works. Literally just drop it into ChatGPT or an LLM, have it go through it. Ask it to go into more details, go into more files, whatever. For now, we're speedrunning, so it's going to do this. So now we're going to use our MTA one for now and just do it. It's going to literally just send us a new one for MTA housing. Great. So this is our new asset sending us. For simplicity, I have it just send us the whole file to make it simple. So over here, we're going to go back to tell us where it was. Great. Great. Oh. Great. Cool. So now they told us to update in three places. So we're just going to dump it in and we're going to see if it was right. So we're going to go back here. And let me just close out this one. Make sure these are all closed. So you don't want to have two DAXs running at once. Great. Cool. Cool. So now same process. Same flow for setting up your assets that it was just in. And ideally, because of the way we designed it, which I'll show you in a sec, it should just work for doing that. Cool. So let's see. Nice. Okay, so it worked. So now we're going to open up our DAXer, which we did before for MTA, and we're going to take a look. And we have a new asset right here, NYC housing. Great. So let's just try it out. Let's just materialize it and see what happens. All right. Great. So we're going to try to see this new asset we just downloaded. We're going to see if it works. So what Dax is going to do is going to start a run. This is basically telling one of your workers, hey, make an API call, go get this data. So now it's going to go start the process and making the API call. It's 100,000 rows, so it might take a little second. Oh, not too bad. So, and then like instructions set in the past for debugging, I made it do this to send the simple sample of the rows. So I'm going to provide that back to Grok. And then I'm going to go with this just to show you guys, because this is a common problem that happens with the Socrata. So we just download this, but the run. So this simple tool I made, FP, show Parquet. So it's just literally just meant to show the schema of the Parquet file you're downloading. A common thing that happens with Socrata is when they send you the data, it's going to be all strings, which is annoying because now if you don't make this, a lot of the queries involve numbers or dates aren't going to work very well. So we're going to make an asset-specific processing function to make this. So now, cool. Now I'm going to go back here. And literally just copy the data dictionary. Okay. Cool. So now what we're doing here is we're telling LLM, okay, we have our data, we confirm it, we can download it, but it's the wrong type. What we want to do is like while it's still a polar data frame, but before we make it a Parquet file, we want to just do a little processing to make it so we already have the data in the right format we want instead of once it's there. Cool. So this is the one it's doing over here. So let's see if it works. It's going to say these. It's making the ones text, and then cool. Are they all text actually? Well, one should be date. Whatever. We'll see how it goes. And so we're going to copy this. We're going to go here. It gave us a new processing function. So this is the one it just made for us here. So now it's done. We're going to run it again. So we're just going to delete that. I'm going to go back. We're going to run it again. So we'll see if there's an error. I'm going to fold it here just in case there's an error of some sort, which I can then just send to Grok. But hopefully it doesn't. Hopefully it just like one-shots it, which it probably does maybe % of the time. Okay, great. So now it downloaded one. Let's check this one out. That's too bad. Although this one might have been just a bit. Let's see. Now we can just tell Grok, hey. Oh, maybe it's because I didn't do some of this one. Maybe that's why. I forgot a part. Forgot to send in the updated one here. Because we changed that, we need to change the asset a little bit. So I'm going to cut this. Mode. Now let's try it. Great. Okay, now it worked because we changed it. So now Grok was able to do what we did now instead of just directly taking the data frame, making a Parquet file. Grok or code once it's already in memory in this part right here. Once we have it downloaded, we're actually going to be then doing a processing function over here, process New York City, which we just created over here. Which now we have the ones we want in the right format. So now the date is the date. Cool. This one in particular can have a lot of bad ones or any numbers, but you get the point. Cool. So now I can save this. Now, see what time I got. Okay, cool. I got time. Now, cool. Now, what's interesting is like with when it comes to kind of code and LLMs, some stuff that might have been really annoying for a human to do is like, I'm going to avoid making my code in some way because that's annoying. It becomes costly with an LLM. For example, I'm putting the data dictionary into it. It's simple as copy and paste and just do it for me. So I'm going to go over here. I'm going to drop it in. Why didn't this work before? I do want that, but we'll see. Oh, hang on. What the hell? All right, well, I messed something up before. Let me see if it's actually in there. I can do it now. Anyway, what we can do now is accept another thing for this. So I'm just going to do this actually. Copy. New thing with Grok. Cool. Now we're going to go back here and we're going to give Grok another prompt for able to do querying. So now, hey, I just gave you a dictionary. Let's make some queries about it. Cool. So now it's going to analyze the schema I just provided for the data set. So now it's going to know what it's doing, and then it's going to decide some stuff to do. So now it's going to give us some basic ones to query. So now let's see if these work. So Go Harlequin. Oh, let's do this. Great. So now the data we just downloaded from Socrata, we can now kind of query easily with SQL, which, okay. Now we're going to take these from what we've got over here. We want to see if they work, Okay, great. Checking data quality. Nice. That's pretty good. Now, okay. Now let's do some basic stuff. Evictions by borough. Let's try that. Okay, great. Evictions by borough. That's not bad. So now what we're going to do here. Which I think add it to now the DBT. So we'll make this. I'll leave them in there. Actually, not leave them. Make it over here in transformations. Where's my things? So great. And so then one small thing over here is needing to do a deal. Great. So now in order to use DBT, you have one simple thing here. So now what we have is, so what I'm going to do actually just for the sake of this, to make it simpler, I'm going to delete the existing ones. So our existing code, I'm just going to get rid of. And then we're going to go over here to the warehouse. Just get rid of those. Just to make it faster. Great. So now we said, oh, and one last one in the sources. Great. So we changed a few spots. So now we're going to go here. And we're going to start the process again. I always forget this part where in order to do it, you gotta remove that little last thing. LMs always will do that. Always have to take it off. Okay, cool. Yeah, damn. Yeah, you gotta do it stuff. I'm just gonna move on. The point is that you can be able to do stuff. It's still a work in progress to be able to do one-shot LMs. You take a risk when you do it live, but the point is that you can, with a little bit of work, you're not supposed to be able to one-shot stuff. The point of LMs is you can actually test them locally, and then you fix the mistakes. So for the time being, because we're running a long time, I'm going to skip this part, unfortunately, which it happens. Sometimes live demos don't work. And so I'm going to do that. So now we're going to shape a different part. Maybe hopefully this one will work. This will demo this showcase working with those really big data sets. So let's say, for example, like the ones that are really big for like the LLM, like the origin destination data sets for Subway or for elsewhere. It's always hard sometimes to download from Socrata. It takes several hours sometimes. So now, as an example of what could maybe possibly be a better way to do things in the future, what if like instead of sending JSON for that, we can just send Parquet files? What if we can assume that the other person on the other end of the spectrum already has the data downloaded? For example, what if you want to download the 311 data set, which is, 40 million rows? Like it takes some time usually to download it. So I'm going to go here and I'm just going to click materialize. So instead of downloading from Socrata, I've already done that. I put it in my public R2 bucket. Let's put right here. From Hub in the R2 bucket, instead we're going to be downloading tens of million rows in minutes, or maybe even a minute instead of seconds. So cool. So instead of getting Parquet, we're getting Parquet files, which are already like that. It's going to be putting over here. And it's just speeding along, downloading them by month, and now it's already organized. So now when you want to work with this 311 data, you can easily, work with only the year you want or the month you want. The data is already kind of separated out. It allows you to work with these larger data sets without having such a strong local computer. Cool. And then in order to change out like how it works, or in order to like, hey, I want to download less time from it or anything like that, it's really as simple as just changing the start and end dates for when you do it. So a simple example for that, where it's like, okay, great. And now it's downloading. Yeah, see how fast we're gonna get it. Yeah, could have been faster. But we're at a minute and 12 now, and we've downloaded 85%. I don't know. But the point is for this is you're able to now work with these larger data sets and download them by able to download them fast. Now we can work with them and go with it as opposed to having to wait hours for it to get from Strata when for these bigger analytics data sets. Okay, and then this is the last ones, 30 more seconds, just so I can show. Great. So now cool. So now we can work with our SwiftMall. Great, 30 million rows for the NYC 311 data set. Download in 2 minutes, ready to go. And then, so another thing that's really beautiful as well about building with open source data standards is it's not just about, like once you need to move it elsewhere, or it has to be open source. I can't use a data platform, or it has to be all that. What's beauty about open data standards is it allows us to work and expand out when we need, bigger power in the cloud because we actually have bigger data sets or we need automation, or for whatever reason. We can now work with the same tools we're using locally with that. So as part of that, one of our kind of integration partners is Cloudplan, who they kind of created over here, a serverless platform for being able to run large data jobs using just Python and using the already existing open data tools you have. If you want, they've opened up their kind of thing for a week for Open Data Week. If you want to be able to use their kind of tools, it's also in the appendix at the end if you want to sign up for this later. Cool. So what we can do is using the same code we already have locally, we can also now run the cloud for bigger ones. So for example, the New York City tag data set, it's a little bigger than you can do locally. It's about 900 million rows. A little too big, not really worth it to like download and do locally. So our goal is to now predict the models for being able to query it. So now let's go here. What's also really cool about UV is as modern tools is it allows you to have optional dependencies. So extra Cloudplan. So this is just gonna solve. Oh, forgot to have my Venva. That's too bad. But oops. Well, now what we can do is actually run right in the cloud things right there that wouldn't have been possible before. So now, for example, if we want to be able to run like a simple one for a data pipeline that will run an ML model, what we can do is simply just run it, and it's going to be running that same code we'd be having locally, that we'd be using the same tools, same data we've just from open data. It's actually running out in the cloud. We can do it here instead. We're also able to kind of query, and so we can run it there. And now by using the same tools, from when you have privacy concerns, you need to do more. It's easy to now work with any data platform. You don't have to become locked in. You can easily move to another one because we're using open standards as opposed to the past where platforms lock you in. Cool. And now you can also run That's weird, really. Cool. Now, for example, if now this bigger data sets, you want to run a query on it, like for example, I've done here, which is a very simple query. It's just going to be checking out for the select all count from their taxi, the taxi asset, which is a pretty big one. But it takes a second to spin up usually, but then after that, you're good to go. Now, about 900 million rows now in a count of seconds, while working in laptop with the same flow. Now, that's kind of the power of what you can do here using open source data tools, where it allows you to, even though you're working locally with one set of tools, you can expand out. You don't have to choose and become locked into a vendor. You can always move around to another one because they're open source standards. Cool. Amazing. So now let's finish up. Been talking for a while, and I'm going to do this. So now let's talk about a little bit about future work for what I'm working on with the kind of open data stack. New York City specifically is where I'm going to be focused. And these are some of the different things that we can use to expand out, which can make this a lot better. There's data normalization across all the different data sets. Just doing a little more effort to make the column standard. How do we find a date column? How do we do multi-asset joins across, to make the 311 data set better with like the CD number, with our community demographic data? Can we have automated scheduling upstream? Instead of having to do all the work at the code level, can we work with upstream agencies to understand their data frequency pattern? Do a one-time backfill of old bad data, like in the 311 data set. Building out forums to be able to make it for people to contribute, to give reputation. Oh, I trust this data pipeline. I'm giving my stamp of approval to it. These are all things that make it easier to trust the data we build out to build New York City. And there's also stuff to do in, open data in general around, better use of open tables, better use of open lineage logging for being able to have full open source, easier for automated scheduling, multi-step transformations. There's entire dimensions of ways we can grow and use these open data tools. And I'm just going to be planning to just keep chipping away, starting simple, then going from there. And now my closing thoughts. I apologize for not leaving too much time for Q&A, but these things happen sometimes. Now, number one closing thought I want to leave with you on, fundamentally update your understanding of data engineering and choose to switch over to these open source tools. If you ever use Excel, it's literally easier to use local code like with an LLM than it is to build an Excel formula. Just embrace that and be able to build different workflows local first around open source tools. You don't need to pay for that data platform probably. Do you have billions of rows? If not, probably not. You don't need to pay for it. Embrace coding for everyone on this call. I don't care if you think, oh, I'm not technical, or, oh, no, it's useless for me. There'll always be better coders. That's wrong. This is now the case. Think of your computer not like some glorified thing to stream and like look at Facebook, Twitter, or anything like that. Think of it like an infinity box. Anything you can think of and what you want to do, any tool you want, anything you can do, you can now do on your computer. The LLM, you can just have to say what you want, be explicit, and they can do it for you. Learn to work codely. It doesn't have to just be, oh, I can code, I need to work for a tech company, or I need to build a SaaS app. There's a whole middle ground of like, oh, I just use code locally to help me do my job, to speed things up, to avoid Excel dying out on me. Just embrace it. It's here, and it's not as hard as you would think. Everyone should learn how to do it. And in general, embrace single machine and local first workflow. And this is a little bit more of a story. IBM in the 1970s was a dominant. Their mainframes, those were what enterprise used to conduct, the computers. In order to use computers, you needed to invest in the IBM, big, powerful mainframe. You can do it. But then open source came for IBM. Unix, open source operating system, combined with Intel and like lower commodity hardware, it made it more possible to avoid the mainframe, to create alternative software. The personal computer came out, and even though it was not nearly as powerful as these big, powerful mainframes, there's plenty of people that had use of small amounts of computing power and they can do locally. I believe that same is going to play out here in data. Even though you might want to have a distributed computing platform and all that, it has more power. The utility and impact, though, is going to be on PC, on individuals being able to work with data who couldn't otherwise, but not having to invest in a data platform, not having to pay money. And that's what I like closing thought. And my last closing thought for you, and it should be a challenge to everyone here. New York City should be the global open data leader. We have the best open data laws in the world, which already give us a strong footing. We have an incredible concentration of data talent here in New York City working on this stuff. And we have the best capital formation in the world. We have endless amounts of investors who are able to finance these things. If New York City doesn't become the global leader in the open data revolution, that's just a bag fumble for everyone involved. And that's my last thought for that. And I'll leave a grand spanking 5 minutes for Q&A.
So a few questions in the chat. So the first question was, what extensive is the SQL query view you are using?
Which extension? Oh, Harley Quinn is the code for it. It's called Harley Quinn. It's a really cool terminal SOAP SQL editor. It uses DuckDB to let you run SQL codes. DuckDB recently came out with their own UI as well, which you can check out. I haven't used it, so I don't want to. Harley Quinn I like a lot because you can just run SQL and it has a pretty nice editor right there. I think the best recommendation for articulating it is to show them that, you know what, find like use cases that, you know, aren't mission critical, that aren't going to like, oh, if doesn't break, like don't use it for the MTA like assets. Like there's something that people rely on, but find one that's static. You typically static BI is probably the best place for it now, where we can tolerate 24 hours latency. Find a single use case that, hey, we're spending a lot, or this we couldn't get approval for this budget to like try and add it to the warehouse. Use these tools to just build it out. And then cool. And then I think starting off with like to end the example, I think you need to feel these tools and feel the speed, feel working with millions of rows like that. Appreciate, oh, this is different. This is not what we had before. Daniel Alvarez, no specific licenses are needed for the tools. They're all freely open source. Some of them have a paid plan for more extended features, like Evidence, for example, has one for being able to post on their site and like private stuff. But every tool I've decided to use is freely open source, and that's the point. You should be able to just do all this stuff with just pure code. It should be freely available for everyone else to run, validate, and check your work on. How do I keep up? There's stuff there is on X right now on Twitter. It is unfortunate, like the kind of still the best place for like open for new stuff coming out. The people that are building on this stuff, as a lot of them are there and building. Other than that, pretty much just like you need to use these tools yourself. Join some open source communities, learn a little bit. But if you want to learn, use the tools yourselves. You can only read so much, and that's what I found. You need to just use the tools, and that's like your best way to learn. Learn by doing. Since I work so very fitting lightning fast. Apologize for if I kind of like sped a little too fast or anything was confusing. Was barely able to limit the time, and then I apologize that Grok was not able to kind of get the going. I have to check it out. There's a little bit of a risk to take on the make it real time, but the point is you can do that. And also why LLMs and coding are a very good pair. A lot of times hallucinations from LLMs are really bad. Oh, if it like made up something, it didn't work. That's really bad. But with coding, you immediately check its work. You have a very good feedback loop. That's why if you're going to be using LLMs, coding is probably the number one use case for it. Got it. Yeah, definitely going to need to slow down in the future. It's looking like that seems to be the consensus. But I do hope it was cool. And then last thing I will say for everyone, if anything I said here was interesting at all, if you're interested in open source data engineering, open source or building public good data pipelines, if you want to make something useful for the city, if you want to build something, if you're a student and you want to learn how to use these tools, if you're anyone, hit me up. Hit Christian at theopendatastack.com or hit me up on Twitter, CasazaNY. Send me a message. Send it whatever way you can. I'll reach out back out to you. Like I'm really right now, the number one thing I would want, use cases. If you're a city employee or nonprofit especially, and you just have anything where, oh, I would like this to exist, send me a message and I'll build it for you. Because right now, again, the best thing is to just learn by doing. We have a wide open space for open data engineering to come in, get started, find a shovel and start digging away. Start learning how to use these tools, and I think you will find success in the future. And I think that's it.